Welcome to The Explainer. Today we're going to talk about gRPC, a really powerful framework from Google that's kind of changing the game for how services talk to each other. So if you think you've got APIs all figured out, you might want to stick around. So what's the big deal with gRPC? Well, it really starts with a completely different way of thinking about what an API even is, especially compared to the REST model most of us have been using for years. And this question right here, this gets to the absolute heart of the RPC, or remote procedure call philosophy. Instead of thinking about data and where you store it, RPC is all about what you can do. It's about actions. Think about it. With REST, you're always focused on resources, the nouns, and you use a set of verbs like get, post, or delete on them. You're basically saying, hey server, I want the resource named user with the ID 123. But RPC flips that. It's all about the verbs, the actions. You just call a function directly, like getUser, and pass it the arguments it needs. It seems like a small difference, but it's a huge shift in mindset. And that's exactly where gRPC comes into the picture. It's the modern, totally supercharged version of this action-first philosophy. It was actually born inside Google, where they needed something that could handle the massive scale of their distributed systems. So it was built from the ground up for just one thing: performance. Okay, so how does gRPC actually pull off this incredible performance? Well, the secret, the real magic under the hood, is a technology called protocol buffers. You'll usually just hear it called protobuf. Honestly, protobuf is the heart and soul of gRPC. It has two incredibly important jobs. First, it's the blueprint for your entire API. It defines a very strict contract between your services. And second, it's the engine that serializes your data, packing it into a super efficient format before sending it across the network. And it all starts with one of these. This is a simple .proto file, and it's actually pretty easy to read. This is where you define your services, the methods they have, and the exact structure of the messages you'll be sending back and forth. This creates a rock-solid typed contract before you ever write a single line of application code. And this is really the secret to gRPC's speed. You know, unlike JSON, which is text-based and human-readable, protobuf takes your data and compiles it down into a tiny, highly optimized binary format. And it's just simple physics, right? The smaller the data, the faster it can travel across the wire. And this image right here perfectly captures that trade-off. What you're looking at is the raw binary stream. To us, it's just a jumble of bytes. But for a computer, it's ridiculously fast to process. This is exactly why you can't just pop open your browser's network tab and see a nice, clean JSON object. You're trading that human readability for pure, raw speed. So that's the tech. But what does this actually look like for a developer day-to-day? Well, it's all built around this idea of an API-first workflow. The workflow is actually really elegant. First, you define that contract in your proto file. Then you run a special compiler, and this is the magic part. It automatically generates all of the boilerplate networking code for you. It creates code for both the client and the server. So all that's left for you to do is step 3, implement your actual business logic. You get to focus on what makes your app special, not the plumbing. This diagram really helps visualize it. That code that gets auto-generated, we call those stubs. They act as the bridge. So your application code just talks to the stub. The stub then talks to the gRPC runtime, which handles all the really nitty-gritty stuff, like serialization and sending data over HTTP/2. The end result is that, from your application's point of view, it just feels like you're calling a function that's running right there in your own code. But gRPC is way more than just a faster version of a simple request and response. It has some genuine superpowers, especially when you start talking about streaming data. So it actually supports 4 different types of calls. The first one, unary, is the classic model we all know. Client sends one message, server sends one response. Easy. But then it gets really interesting. With server streaming, a client can send one request and get a whole stream of messages back over time. With client streaming, it's the opposite. The client can stream a bunch of messages and then get a single response at the end. And with bidirectional, well, it's a free-for-all. Both the client and the server can send messages whenever they want. And having this streaming built in from day one unlocks a whole universe of applications that are, frankly, a huge pain to build with traditional REST APIs. We're talking about things like pushing live notifications to a user, efficiently uploading a massive file in little chunks, or building fully interactive services like a chat app. I mean, gRPC was literally made for this kind of stuff. Okay,
So gRPC is clearly very, very powerful. But, and there's always a but, right? That doesn't mean it's the perfect choice for every single project. Let's be real and break down the trade-offs you have to think about.
At the end of the day, it's a classic engineering trade-off. On one side of the scale, you get absolutely incredible performance, native streaming, and that super strong API contract that can wipe out entire categories of bugs before they even happen. That's the awesome part. But on the other side, you've got the downsides. It doesn't work in a web browser out of the box. That code generation step adds a little complexity to your build pipelines, and trying to debug that binary data stream, yeah, it's not as simple as just looking at some pretty JSON. And that really brings us right back to the one fundamental question you have to ask yourself. For whatever you're building next, is that raw, unadulterated performance worth the added operational complexity? gRPC is an incredibly powerful tool, for sure, but like any tool, the real skill is knowing when it's the right one for the job.